Tokyo Superlight blocks are made using cement, sand, and a foaming compound. These blocks consist of tiny air bubbles coated with cement sand grout, resulting in a lighter weight block compared to a traditional block. The technology adopted is called cellular lightweight concrete. Special features of Tokyo Superlight blocks are they are lightweight, they have the highest compressive strength, low water absorption, high thermal insulation, smooth finish on walls, good sound insulation, fire resistance, one saves on steel reinforcement, and one can build them a lot faster. Now let's compare the properties of Tokyo Superlight with traditionally used clay bricks and cement sand blocks. First, let's compare the density. The density of a normal clay brick is 1,900 kilograms per meters cubed. It is 2.5 times heavier than the Tokyo Superlight block. The density of the cement sand block is 2,065 kilograms per meters cubed. It is 2.5 times heavier than the Tokyo Superlight block. The density of the Superlight block is 800 kilograms per meters cubed. Now let's compare the strength of the blocks. First, the clay brick. The strength is 0.5 to 1 Newton per millimeter squared. See how the brick collapses under load? Next is the cement sand block. The strength is 1.5 to 2 newtons per millimeter squared. See how the cement sand block crushes under the load. Finally, the Tokyo Superlight block. The strength is 2 to 5 newtons per millimeter squared. See how the Superlight block performs under load. It never collapses or crushes like a clay brick or a normal cement sand block. We then did a drop test. The cement sand block, when dropped, breaks into small pieces. The Tokyo Superlight block, when dropped, breaks into 2 pieces. See how strong the Tokyo Superlight block is? We then did a water absorption test. Samples were placed in an oven maintained at 120 degrees Celsius for 24 hours, taken out, weighed, and put into a water bath. See how air bubbles are popping up from the clay brick and cement sand block, indicating high porosity. No air bubbles appeared from the Tokyo Superlight block. The clay brick's water absorption is 22%. The cement sand block's water absorption is 24%. However, the Tokyo Superlight block only absorbs 12% of water.
And take it off.
Let's compare the stability of walls constructed using different types of blocks under fire. 2 walls were constructed side by side using Superlight blocks and cement sand blocks. The walls were subjected to a fire at temperatures of 800 to 1,000 degrees Celsius and then continuously observed. The wall constructed using the cement sand block started to tilt within 30 minutes, whereas the wall constructed using the Tokyo Superlight block was stable even after 4 hours. Tokyo Superlight is clearly a stronger block than the traditional cement sand block when under fire. Let's see how the Superlight block performs as an energy-saving block. We constructed a 5 meter by 5 meter by 2.5 meter room and observed the temperature variation inside the room with respect to outside temperature for 3 days. The ambient exterior daytime temperature is 35 degrees Celsius. The ambient exterior nighttime temperature is 25 degrees Celsius. The indoor temperature remained between 27 to 30 degrees Celsius, whilst even the outside temperature rose to over 36 degrees Celsius. It is clear from this that the Tokyo Superlight block substantially reduces peak energy consumption, resulting in financial savings for homeowners, in addition to the comfort of living and a pleasant interior climate. The Superlight block reduces the outside sound by over 35%. Now let's compare building a wall with all 3 types of blocks. All walls are of the same area. The time taken to build the Tokyo Superlight wall was 49 minutes. The time taken to build the cement sand block wall was 57 minutes. The time taken to build the clay brick wall was 103 minutes. standardize the results, we have calculated this information into a scenario of building a 100-meter squared wall. The results were stunning. A. The number of cement sand blocks required to build a 100-meter squared wall is twice that of the number of Tokyo Superlight blocks required. Even more shocking is that we would require 6 times the number of clay bricks to cover the same surface area. B. The mortar required to build this 100-meter squared cement sand block wall is twice the mortar used to build a Tokyo Superlight wall. While if we were to build the same wall out of bricks, it would require triple the mortar to complete. The smooth surface of the Tokyo Superlight blocks also means that the amount of plaster required is minimal compared to that of the existing alternatives. The plaster required for a cement sand wall is 5 times that which is required for a Tokyo Superlight wall. The clay brick wall requires almost 7 times the amount of plaster to that of a Tokyo Superlight wall. D. The time it takes to build a Tokyo Superlight wall is half that of the time it takes to build a brick wall, and 10% less than the time it takes to build a wall out of cement sand blocks. E. The final dead loads for each wall after mortar and plastering provide quite sparse results. With a wall built out of Tokyo Superlight weighing 40% less than a clay brick wall of the same size, and more than 60% less than a cement sand wall. Imagine the savings on steel reinforcement if you were building a skyscraper. The fourth wall, masonry, mortar, and skim coating. We built a fourth wall to showcase 2 unique properties of our complementary products. A. 1. We switch out the traditional masonry mortar with our specially designed Tokyo SUPERSET block fix. This mortar can be mixed by just adding water to the contents of the bag. Unlike regular mortar that requires a layer of 10 to 15 millimeters before you fasten the next block on top, Tokyo SUPERSET block fix, the Tokyo Superlight blocks, requires only a 3 to 5 millimeter layer between blocks due to the specially fabricated adhesive nature of this mortar, designed explicitly to bond to Tokyo Superlight's quality control smooth finish. B. Tokyo Superlight's smooth finish brings us to the second reason why we built this fourth wall. It is to demonstrate that the finish on the wall is of such a high caliber that you don't actually need to use a traditional layer of plaster, but just apply a skim coat directly to the block. This essentially removes an entire step in material out of the construction process, if the effect shown here is the aesthetic that you are aiming for. However, if you do wish to apply plaster, Tokyo Supercast plaster is available for external and internal use. Some other qualities that cement Tokyo Superlight as a superior building material are those experienced during implementation and actually building a wall. Let's see how utilities like power and water lines are fixed onto Tokyo Superlight walls. All one needs to do is mark the area, cut with the grinder, remove the grout layer, and fix the lines. See how neat it is? So, we hope that we've introduced this revolutionary new product in a manner that helps you best understand all the new advantages it will allow you on your construction site. So join us in this new first